Alright, so here's the schematic, and this section over here are all the optocoupler track drivers, and this section all works. When you turn the all on switch, it activates all of these and they all go on. So the middle section, all of this are the filters, active filters. So it's either that section, this section, which is the volume gain control, or the actual microphone, or I'm just not hitting the right frequencies to make this thing lights light up. So I did text, or I emailed the manufacturer, because they said if I did all that and it didn't work, to let them know. So we're going to find out from them what the next option is. I'm thinking to get a frequency generator and put in specific tones into the filter section and see if it turns the individual triac sections on. To be continued. Good evening. Thursday, December 8th, 2022, working on a color organ project. It was not picking up any sounds, nothing was firing. We did a little troubleshooting. Let's have a look and see what we found. So we've hooked up a function generator and an oscilloscope. We have the function generator going through a 1K resistor to a signal point, and then we have the scope lead connected back to the scope. So that's what we're putting in from our frequency generator here. So we're gonna sweep from all the way down about 400 hertz. See, we're gonna sweep that up. See how it's changing? That's on the input. Okay, and then we're going to go over and see what's happening with the lights. So on the diagram, that signal input is right here. So we're coming in from a frequency generator through a 1K to this point here, which goes up into this amplifier gain control circuit. I'm going to turn off the light so we can see what's going on with those lights here. Okay, so there's the front panel lights. So this is about 400 hertz. We're sweeping up. Oh, so now we have one light on, sweeping up a little bit more. We got two lights on. We got 3 and 4 lights on. And then we're like dropping the middle one but keeping the lower ones. So what does that mean? So what that means is that these are the active filters that pick up different frequency bands and then trigger the triac, the outputs, which make those little LED handles light up. So these are lighting up. These bandpass filters are sensing something, and they are turning on and off. So these ICs and circuitry seem to be good. The issue is that that's like 2 volts peak to peak going into the signal point, and that's supposed to be a microphone input, which is like millivolts. So we need to put in at least 2 volts. So it would indicate that this amplifier is not amplifying the way it should be, because it shouldn't take 2 volts to turn those circuits on. You know, we're like 3 orders of magnitude too high. And in looking, this FET input here, Q11, if we look on our board, okay, so here's Q11 right here, and what we see is that this is the flat side, and it is installed the wrong way because it needs to be the flat side on this side. So this transistor is rotated, so we have the wrong leads in the wrong spot. We will now try to unsolder this one and put it in the right way and resolder it. So we'll have to get the desoldering station hooked up and see if we can pull that transistor out of there without damaging it. So we were using a soldering iron, and so now we hooked up to this side the solder sucker. When you press this button, it provides suction, and so we used it over here to heat up the solder gun, and then you suck the solder out, and then you can remove the part, and then we put it back in the right way and resoldered it. So it is hopefully now back in the right way, right there. Alright, we have the transistor in the correct way. We fired it back up, and let's see what's going to happen. We've had to put a 33K resistor instead of a 1K, and now we are putting in, that's what it's seeing is about 10 millivolts. I think we're putting in about 100 millivolts, 0.1 volts. And let's see what our light's going to do. So we're around 20 hertz. Here we're going 20, no, that was 200, so 400. We're a little bit above 400 there. Now we're getting up to 500. We're like 700. We're like 800. So it seems to be responding a much lower voltage level, and I think if we go up high enough, the low ends will start cutting off now. Let's see. Still might be too much, but the voltage is turned this down as far as we can. Let's yeah, alright, so now we're, yeah, so now 10K, so 6,000, 7,000, starting to cut off some. We're up around 10,000. Yep, so 13,000 is starting to cut off. Yeah, alright. So it looks like it might be working. I think we might have too much amplitude coming out of our function generator, but it's turned all the way down and the attenuation button is on, so that's the lowest we can put in there right now. Okay, let's put the microphone back on and see what it looks like. Not the most accurate instrument to test, but here's a little keyboard, kid's keyboard. Now let's look at the different bands and let's try. Let's see if we can see. Okay, so let's start low. So I think we're picking up a lot of harmonics or noise on the signal. So let's take a look at the scope. So that's a low frequency, but you can see all the harmonics and stuff on there. So I think that's why it's triggering up higher ones too. So that is 3 milliseconds, so 300 hertz. So 1 millisecond is 1,000 hertz. That doesn't sound quite right. A millisecond is 1,000 hertz. So that's like 1,000 hertz. But look at all the other stuff that's on there. This is on the output of the preamp. Yep. Alright. I think our main board and our control panel board seem like they're functioning. So now we have to get some outlets and some lights in a enclosure and mount it all together so we can actually like take it upstairs and put it in the room with this when the kids are playing and yelling and screaming and talking. The different Christmas lights in the room are going to be going off. That's the next step, is to get this box into an enclosure that's somewhat kid safe, so no one gets too hurt. But it can still see all the workings of it. That was the intent. They could be like marveled with electronics and the lights that are going to be connected to it and